welcome back to this course on C programming and assembly language. In the last module, we looked at how to compile a C program and how to translate local variables into EBP minus some offset, how to translate function parameters to EBP plus offset, and so on, right? In this module, we will use that information that we have learned in module 3 and look at the impact of certain corner cases in C programming, right? And we'll also look at some special functions like printf and so on. So in this lecture, I would like to discuss the following, right? I want to look at passing arguments to a function, right? So this is a precursor to studying what we have to do in printf, right? So let us look at two cases specifically here, right? So first is we have a function fn which takes some set number of arguments. We have a so let's say there is a function fn which takes let's say two arguments, int x and int y. Okay. So what I want to study is I want to see what happens when I invoke this function with fewer arguments and when I invoke this function with more number of arguments than what has been defined. Okay. So case 1 is passing fewer arguments, right, and the case 2 is more arguments. So let us actually go back and look at our compiler explorer tool, right, and understand what happens here. So so we have a function fn which takes two arguments x and y, and let us say it just returns x plus y. The function can actually do anything, it is just a dummy function. Okay. The main focus is the arguments x and y here. Now in main what I am doing is I have three variables x, y and z initialized to 0, 1 and 2 respectively. So normally I would invoke this function fn as fn of say x and y, right. So this is the right way to do it, and as you can see there are no warnings or no errors on the right hand side here, and the program has got compiled to its assembly output appropriately, right. Now the question is, if I remove this y, then what happens? So clearly remember that here I am dealing with a C program, right. This is not C++, this is a pure C program. So it is essentially saying that fn too few arguments for call, right, which is understandable because the function fn has been defined to take two variables x and y as arguments. So let us note this down. If you pass fewer arguments than what has been defined, right, this will give a compiler error. Now on the other hand, if I just call it as f of x comma y comma z, right, which means I am passing three variables to it, right, then what happens is that I see that there is a warning fn too many actual parameters, right. There is just a warning here, but the program still gets compiled to its appropriate output without any problem, right. So if we instead passed more arguments than what has been defined, you would get a compiler warning. The point is whether it is a warning or an error is up to how the person wanted to implement a compiler. It really does not matter. Okay. So By the way, this is not restricted only to MSVC. You could go and try your hand at compiling this even with GCC, right? And yeah, so it turns out that GCC gives an error, right? Too many arguments to Fn, right? And GCC, of course, if you call it with fewer arguments, will also give you the error saying too few arguments to function Fn, right? So the point is whether it's an error or a warning is actually up to the implementation of the compiler. Now, if you pass fewer arguments than what has been defined, then all compilers will definitely give you an error, right? But if you pass more arguments than needed, right, like this x, y and z, then it is the choice of whether to throw a warning or an error is compiler dependent, right? And that is what we are going to analyze and see what the impact of passing these extra arguments is at an assembly language level, right? So if you look at MSVC, we are back to MSVC 19.10 version here, and this only throws a warning if you pass more number of arguments to it. So the question is now, what happens when I pass more number of arguments than what has been defined, right? So let's look at our function Fn, int Fn of int x comma int y, right? Now we already know that the arguments are pushed onto stack before calling the function, so therefore both x and y will be accessed as contents of EBP plus something, right, at EBP plus 8. Okay, so x will essentially be contents of EBP plus 8 and y will be contents of EBP plus 12 if it is a C program, right. If it is a C++ program, then the offset will be slightly more as discussed earlier. Now in my main, I am going to call this function in two different ways, okay. So the first way is case 1, I am going to only call it with x, okay. I am saying int x, y and z, okay. So how does this particular function call get translated to assembly? So you say push x, which is EB contents of EBP minus 4, okay, and then you are going to say call Fn. So if you look at this particular stack, what happens is you have the local variables, right, of main, right, this is local variables of main, right. Then you are pushing EBP minus 4 onto stack, right, contents of EBP minus 4, which is basically the local variable x, and then you are calling the function. So what happens is there is a return address that gets pushed onto stack, okay, and then you enter the function Fn, where as usual you push EBP to stack and all those prologue happens appropriately, right. So there are this is EBP of main, right, and then this is my local variable space of Fn. Now if you look at this particular, and by the way this is the stack. So if you look at this particular implementation, and let us assume that we are able to translate this program to assembly language without any compiler error, right, then what is going to happen is in the function Fn you are going to access these two locations EBP plus 8, which is basically this guy, right, EBP plus 8, because when I enter the function Fn, remember that my EBP will be pointing here, right? Then in the prologue we would have moved the EBP to point to ESP before allocating local variable space, right? So my EBP is here, and therefore EBP plus 8 is basically this location, right? Now EBP plus 12 is also going to get accessed in this function, because remember that the function that we implemented out here is return x plus y, okay. So both x and y will get accessed, and y is nothing but EBP plus 12. So what is happening is EBP plus 12 is this particular location, EBP plus 12 is this particular location, which is some garbage value because we have not really even initialized it, right. So some random value from main is getting accessed in this function fn if you pass fewer arguments than what has been defined in the function fn, right. Now on the other hand, let us look at the second case, right. Now let us draw the stack picture for the second case, where in main we are now passing fn of x comma y comma z, right, and this is int x comma y comma z, okay. So how does this get translated to assembly language? It is push z, let us not worry about EBP plus what, you know, for the local variables here, push y, push x, and then call function. So let us now redraw the stack picture out here as well, okay. So again, you know, when I have the local variable space, okay, and so what do? I first push z onto stack, right, then I push y onto stack, and then I push x onto stack, okay. And then of course I am going to do a call, so the return address gets pushed here, and once I enter the function fn, the EBP of main will also get stored here, right. So after all this, EBP will point here, right, and this is my ESP, local variable space for main has been allocated, local variable for main. So now let us look at what happens in the function fn, okay. So the function fn is simply going to access only two locations, right. In fn, x is contents of EBP plus 8 and y is contents of EBP plus 12, right. So EBP plus 8 is this particular location, right, and EBP plus 12 is this particular location. So what has happened is we have pushed an additional variable z onto the stack, but that is really not being accessed in the function fn. So therefore, as far as fn is considered, there are two variables that have been passed to it appropriately. Of course, it takes only the first two variables x and y when it has been called, right. So here it is only these two variables that it will eventually take. Z will just get ignored even though it has been pushed onto the stack, okay. So now what happens is, after the function fn is done, right, when we return and come back to this function here, we do a stack cleanup, right, and if the caller is doing the stack cleanup, right, as is the case by default with underscore underscore cdecal calling convention, then what will happen is this function call fn will get translated to add ESP plus 12, not coming, it will be comma 12. Whereas if I did Fn of x alone, right, which is basically the previous case here, if I did this, then this would get translated to add ESP comma 4. Now in both cases, whether I pass fewer arguments or more number of arguments, stack cleanup is not a problem as long as the stack cleanup is happening when in the caller's domain, right. So that which is the case by default, and hence there is no problem. But in the case when we pass fewer arguments than what is being defined, some garbage value gets accessed, and therefore you will see that all compilers return an error and don't even allow you to compile the program if you pass fewer arguments. But if you pass more number of arguments, there is nothing functionally wrong, the extra argument gets ignored, right, and therefore nothing really happens as far as the function execution is considered. And therefore some compilers may choose to just give you a warning and not worry about calling out the error at that point, right. So at this point it is interesting to ask, saying okay, so will is this always true? I mean, whereas where if I pass more number of function parameters to the function than what is defined, is it always true that the program can get executed correctly while ignoring the extra parameters that have been passed? Well, the answer is not, it's not always true, and I can show you where that will fail. If for example this is an underscore std call, right, fn of int x comma int y, and then I pass 3 variables to it, x, y and z, then you see that this particular function fn gets translated to these arguments, which is push ebp, the usual stuff, and ultimately there is a RET8 which happens. Why is this? Because this is a standard call where the arguments are fixed, okay, and the stack cleanup is happening within the function fn, right. So if I now come here, basically what has happened is I have 3 pushes happening onto stack, right, push z, push y, push x, and then a function call to fn is happening, okay. So what happens is, suppose fn was an std call of int comma int, right, then the function would get translated to assembly and eventually it would finish with RET8. Why RET8? This is tied to the fact that there are 2 integers as arguments, right. Now here the function itself is doing the calling, the stack cleanup, right, and therefore if this function gets called with either lesser or more number of arguments, the compiler should flag an error necessarily, because the functionality will be in trouble when we execute the program here, right. So here for example, if I had a main and I called this function as fn of x comma y comma z, then this would get translated to push z, push y, push x and call fn. The add ESP comma 12 will not happen here because this is an underscore std call and the stack cleanup is happening through RET8. So therefore in this case the extra push that was done, this particular push, the stack cleanup will not happen. So ESP instead of coming down by 12 after the function call fn, it will come down only by 8, and therefore one push would have not been accounted for when we exit main, and therefore it will return to some random address after it completes main, right. So with that we can write down some important conclusions that we have derived from this particular lecture, right. Right, conclusions, right. So cannot pass right to a function, right. I would say it is okay to pass more args to a function if stack cleanup happens basically at the caller, right. But of course if it is a STD call, then stack cleanup is happening within the callee, then you cannot pass more number of arguments, you have to pass exact number of arguments, exact args if happens here, you have no choice. So this conclusion that we have come to is very important when we go ahead and look at the implementation of something like printf, right, where we have variable argument list. We need to make sure that it is possible to pass more number of arguments than what has been defined, right, and yet have this program execute appropriately. And in the next lecture we will look at the implementation of printf in detail.